We're starting some application stuff today with quadratics. And this worksheet I think is definitely going better. I gave this worksheet to my honors Algebra 2 kids, and they struggled through it but persevered in the end. But I decided that it was not a super awesome worksheet. So I'm going to teach it a little differently, meaning you're going to learn how to do it all entirely on your calculator. Okay, so definitely get out your calculators. And you're going to basically just be setting up these equations, and then we'll use our calculators to solve them, which is going to be really, really handy and make this worksheet go a lot smoother. And so definitely want to use your calculator. So it's kind of nice. It'll also reinforce the, you can solve any equation on your calculator, any equation. And that's always a good fail-safe for when in doubt,
drop it off.
Use your damn calculator. All right. There you go. And the length of a rectangle. You should definitely write this stuff down. Oh, and speaking of writing stuff down, I am going to collect your notes.
Yeah, today.
Today, yes. I do collect your notes quarterly, and like I said, I meant to do it last quarter, but then I ended up with strep and was too tired. So tomorrow's PSAT, so I'll hopefully have time to grade them, which is, convenient. All right, so the length of a rectangle is 5 centimeters more than the width. The area is 84 centimeters squared. Find the dimensions of the rectangle. I just have to show you a picture of my daughter because she was so cute today.
Oh, show me.
So today was Bullying Awareness Day, right? Did you know that? So you're supposed to wear blue, which is why I'm wearing blue. But there's my little 5-year-old. Well, the best part is she's like, I need to wear a tiara today.
I see green.
So what?
I see green.
It's blue. It's just her dress. On the video it looks green, but it's
looks like that shirt.
Yeah,
it's blue.
It's really blue.
It's definitely green.
Alright, I just thought you looked so cute. Okay. Alright. Here we go.
Polka dots.
Alright, still recording. Alright, here we go. The length of a rectangle. Ladies and gentlemen, the most important part of solving applications is having an appropriate picture. So since we have a rectangle, I want a picture of a rectangle. And then it says the length of the rectangle is 5 centimeters more than the width. Well, do I know what the width is? No. So I'm going to let W equal the width of my rectangle. Now, this is called rectangle. Funny.
You're mental.
Okay. I should be that for Halloween. Oh my god.
A rectangle?
A rectangle.
What's that?
Oh, just miss the joke. You should.
Okay.
I was a boss.
Can you please do that? That'd be hilarious.
Okay.
It would be such a
Okay. Okay. Sorry. That goes way back. I've always spelled ankle wrong. Okay. Sorry. So I'm going to use W to represent the widths of my rectangle. This is called defining your variables, and you might not necessarily have to do that if you have a well-conceived picture. Okay. And then it says, now we can use one of these sentences to actually translate it from words into math. The length of the rectangle is 5 centimeters more than the width. That is a mathematical sentence. What does it translate into? L equals,
W plus 5.
yeah, W plus 5. So L is the length of our rectangle. And then they also gave us another little bit of information. They said that the area is 84 centimeters squares.
Sorry, Miss.
All right, so they're telling me the area, big A for area. Area equals 84. Well, what else do you know about area? Oh, it's length times width. Very good. So we know length times width is 84. And what can I put in place of the length?
W plus 5.
Yeah, because it's always better to have everything in terms of one letter instead of lots of letters. So in place of the length, we know the length is 5 centimeters more than the width. And so what I have now, I'm going to go ahead and distribute my W, but I don't need to. That's going to give me W squared plus 5W equals 84. So what we've created is a lovely quadratic equation. Now, mathematically speaking, you can solve this by hand. You can set it equal to 0. You can factor or use the quadratic formula, and you can solve, okay? Or you can use your calculator. And the reason that I'm going to show you how to use your calculator to do this is because the worksheet isn't great. It doesn't say round to the nearest tenth or round to the nearest hundredth. It's not very specific, and it changes every time. So it was really, really hard doing this stuff by hand. So we're going to use our calculators. So every single time here, we're going to put one side of the equation in y1 and the other side in y2. And so I'm going to bust out my dueling calculators here. And I'm in my graph menu. Exit.
Bless you, whoever that was.
Okay. And I'm going to type in, now you don't have a W, you have to use X, but it represents W. So X squared plus 5X equals 84. And I'm going to do the same thing on my TI. X squared plus 5X equals 84. Oops, 84. There we go. All right. So I've got my two equations in my calculator. And I'm going to go ahead and do a zoom standard. On the TI, that's really easy. You do zoom standard. On my Casio, viewing window, V window. I'm going to go to viewing window, and it's the STD, stands for standard. Okay. So, it's never going to go over well this time. Only this time. Okay.
Because there's Nicholas's in here.
All right. So, you do zoom standard, and then once you press the standard, you can exit and then draw. And you see, well, here's what I should see. I have the left-hand side. We know that that shape is a parabola, and that's what we're looking at. Then the right-hand side is the equation y equals 84. Y equals 84 is a horizontal line. Where? 84. How high is our y-axis?
It's like
10.
It's like 20.
Okay, it's 10. We need to change our window. So you need to make your window much taller. So you need to change the Y maximum. So we're going to go to window or viewing window and change the Y maximum. And we need it to be at least 84. I'm going to go just for 100. Nice round number, okay? So change that Y maximum to 100. And then you can go and hit graph or exit and draw. And now you see the intersection. You can't see the other one. Let's talk about that in just a second. So you have a graph that looks like this, and all right, it looks kind of like that anyway.
Yeah.
And we can't exactly see this other side, but I can see this intersection. That's the one I'm interested in. How come I don't really care about this intersection? Yeah, it's in negative land. This would be a negative width. Does that make sense? No, it doesn't. We can't have any negative widths, right? So we're only interested in this one. So for all of these, you are going to calculate the intersection, which is the easiest thing to do. So on the TI, you're going to go to the calculate menu. So second, calculate the intersection. And on the Casio, that's under the solving menu, graphing solve, G solve. So second, G solve, really easy on the Casio. You just press ISCT, intersect. And on the TI, you just need to, once you hit intersect, you're going to use the arrow key and move Tinkerbell up to that intersection point and do enter, enter, enter. And you can see that we get 7,84 for our intersection point. What does the 84 represent?
Oh, the area.
The area. That was our area. The area was 84 centimeters squared. Intersect. And then what does the 7 represent? Yeah, we were finding W. So that is the width of the rectangle. Well, so we know the width is 7 centimeters, but they want to know what are the dimensions. What does that mean?
Thanks.
You need to find the length also. Dimensions means we need the length and the width. So that, how do I find the length? Yeah, you add right there. The length is W plus 5. So 7 plus 5 is 12 centimeters. Okay. Again, we don't care about that other intersection because it's in negative land. And these are real life things. So there you go. All right, questions on that? It's pretty easy to do, right?
Do we have to get 12?
Right here,
Oh, no, you just
7
plug it in.
plus 5, yeah. So you have to do calculate.
You have to do
intersection. Intersection, and now move Tinkerbell with the right arrow key to left arrow key, and enter. All right, let's try another one. Example 2. Example 2. A square banner had 4 feet added to its width and 2 feet subtracted from its height.
Oh, yes.
No?
You're so hard.
All right. The banner then had an area of 91 feet squared. How long was a side of the original square banner? Okay, so to get started again, I'm going to draw a picture. And it started out with a square. And this is what we are trying to find. What do you know about a square?
Equal.
All the sides are the same length. You know what those marks are? Congruence markings. Thank you very much. Yes, congruence markings. Okay. So we started out. Now, do I know what the side of this square length is?
No.
No. What do we call that? A variable, yeah, it's unknown. It is the unknown. And so we're going to say let x equal the length of the side of the square. Again, you might not need to write that out longhand if you have a decent picture, okay? And this is nice because that's exactly what we're trying to figure out too. The question is asking how long is the side. So we're trying to figure out x, okay? But then they made some changes. They added 4 to the width. So they made it wider. So if it started at a length of x and you added 4 to the width, what should we write? X plus 4. And then we subtracted 2 feet from its height. So we started at this height and we made it shorter. So how should we, if we started at x, what should we write?
X minus 2.
X minus 2. Okay. So, and then the banner had an area of 91 square feet. So the total area of this banner was 91 feet square. So we know the area was 91. What else do we know about area? Length times width. All right. And what's our length? X plus 4. And what's our width? X minus 2. If you wanted to, we could multiply all this together. Do we need to? No, we don't, because we're just using our calculators, which makes life so much easier. So we're going to go ahead and just plug in y1 and y2. And again, what are you expecting to see? What shape is on the left? A parabola, and it's an up parabola. And it's going to intersect the line y equals 91. 91 is way up high, and we're looking for that point of intersection. I'm going to go ahead and just use the TI for now. Do I need to use the Casio, or are we good? Good. All right, so in y1, I'm going to go ahead and type in x plus 4 and x minus 2. And 91 for y2. The nice thing is my window of 100 is still pretty good, right?
Yeah.
Okay, so I'm going to go ahead and hit graph. There we go. I can still see my intersection point there. I can't quite see the other one. If I wanted to see it, what would I need to do? Extend the x-axis out further. Yeah, so we'd need to change our or x minimum value. If you wanted to, you might have to do that. But I want to, again, calculate the intersection. So we're going to go calculate the intersection. And just move Tinkerbell on the Casio. You just have to, it just does it automatically. And if you want the other one, you just have to press the arrow over and it'll give you the second one. Enter, enter, enter. You only will do it right if it actually tells you the word intersection. If you're not seeing the word intersection, you do not have the answer. Okay? So the intersection is 991. What does the 91 represent? The area. That's what our equation was giving us. It was giving us area. And then, so what does the 9 represent? The x value. And what's our x? Our x is 9, but what does x represent? The length of the side of the original square. Okay? So 9 feet was the side of the square. You have a negative in your parabola. That's right there. It needs to be a subtraction. Wow. All right. Questions on this one? How do you like using your calculator to solve?
I love it.
It's pretty nice, right? Okay, last one. Exactly. So negative 11, well, that's a theoretical answer, not a reality. Example 3, a diver springs from the edge of a cliff 80 feet above the ocean. It is physics. Yeah, it is physics. I took physics my senior year of high school, and all we did was stuff like this, where they gave us like this position equation, and we just calculated stuff, and it saved me. Like calculator physics in college, I could walk in and be like, I'm going to get 100% on this test and actually do it. I got 100% on every test in physics in college. A diver springs from the edge of a cliff 80 feet above the ocean with an initial upward velocity of 8 feet per second. How long will it take the diver to reach the water? Which they really should say, how many seconds does it take the diver to reach the water? How long would imply a length of unit, measurement length, rather than time length. All right. How many seconds does it take the diver to reach the water? They're giving us this vertical motion equation. Pretty standard physics equation. It's a basic equation. It simplifies life a little bit for us. But I'm always going to draw a nice picture because it makes math more entertaining. So here's my cliff. There's my purple diver. All right. And that purple diver is 80 feet above the water. And he's going to dive with an upward velocity. So he's going to launch himself up a little bit, 8 feet per second, and eventually gravity will overtake him. He'll then dive down into the water. Well, what shape does he dive in? It's a parabolic shape. Okay. And so we can use this vertical motion. This is a position equation, which works for most falling objects. And H represents the height of our dude. And T stands for time. In this case, we're talking about seconds. V represents velocity. Velocity is just speed, like miles per hour, or in this case, feet per second. But velocity has a direction. Are we increasing that velocity or decreasing that velocity? So in this case, it's an upward velocity, so it's a positive. It could be a negative velocity as well, going downward. And then C is your initial height. So when time is zero, our dude is 80 feet high. Does that make sense to you? Okay, so that is the initial height of our object, in this case, our purple people eater here. What should I put in place of V? 8. This is our velocity. So that's going to be 8t. And what should we put in place of C? 80 feet. So that's our C value, 80 feet above the water. And so this is our initial setup. But now the question is, how long, which means find T, how long will it take the diver to reach the water? Well, if he's starting way up here at 80 feet high, we want to know when he reaches the water, which is 0 feet high. Does that make sense to you? 80 feet up, we want to know when he gets down here where it's 0 feet. Okay, so we want to know, to hit the water, we want to know when H is equal to 0. So 0 equals negative 16t squared plus 8t plus 80. So we have a left-hand side. Well, this is the right-hand side. I'm going to put in y1. What shape is this parabola? A downward parabola. Yeah, it's negative, so we know it's going to be a downward parabola. And then I'm going to put y2, in y2 I'm going to put a 0. So again, we want to know when we're going to basically hit the x-axis. So I'm going to go ahead and type in my two equations. Negative 16x squared plus 8x plus 80. And we want to know when we're equal to 0. And then again, we can calculate the intersection. So to calculate the intersection and move Tinkerbell to that, as close as I can get to that intersection point. Enter, enter, enter. And it happens at 2.50. What does the 0 represent? The height. Yeah, that's our h. Our h was 0. That's what we're looking for. And what's the 2.5? Seconds. That's the t. Yeah, 2.5 seconds. All right, so 2.5 seconds to reach the water. Look at that, physics and chemistry. Damn, I'm good. Okay. All right. Do you guys have any questions for me? All right. Just so you know, tomorrow.